Hello everybody, welcome to HOTH 10. I have a super scuffed audio setup. Hopefully it sounds alright. You may hear my mouse and my keyboard in the back. But anyways, let's get into an introduction to servers. I know y'all only have 12 hours, so I'll try to keep this brief. This will be just a very high level overview. If you want the slides, they're right here. Here's a QR code and a bit.ly link. And also, I put a lot of effort into this README. There's also a bit.ly link, super simple, intro to servers. It is actually just a GitHub repo. It contains the source code to the demo, as well as a very detailed write-up on basically just an introduction to servers, so what I'll be covering today. But as far as this video is concerned, I will be just doing a high-level overview and getting more into the technical bits during the demo. But without further ado, let's get into it. So what's a server? A server really just is something that takes a request and provides some sort of response based on that request. So just that sentence right there, it really just is semantics for a role, purpose, or behavior of what something does. This can be a computer server. This can be a server at a restaurant. Really, just a server is something that does this whole request and provides a response thing. So what's a hardware server? Hardware server is literally just a computer. It can be a big giant server like Google servers with a bunch of racks and a bunch of computers that are super powerful and handle millions of users. Or it can just be, your laptop, your server. Hopefully not in a pizza box, but if you do, very cool. So what's a software server? Really, it's just a program, just some code that will return some response after a client makes a request. Really, it's just some code. So a server is pretty simple. It really is just semantics calling something a server. Just an example of some server-side frameworks. These are just sort of, server software that helps us write our servers. Without this, it would really be a lot of tedious and just sort of boilerplate code to do things like routing. If you don't know what that means, don't worry about it. Today we'll be making an Express server in the demo. Express utilizes Node.js and JavaScript. Other frameworks are also built for other languages. You see Ruby on Rails and Django for Python. Yeah. So you may have heard the word client before. What's a client? All a client is really just a program or device that makes a request to the server and tries to get back a response from the server. And in our case, our client is probably going to be just a web browser. So like Google, if you pull up the Google web page, your web browser is making a request to Google servers for that web page, and Google servers will give back a response in the form of the Google search web page. So let's get into client-server communication, otherwise known as, in our case, just HTTP, which is Hypertext Transfer Protocol. If you can see the diagram, all HTTP is, it's used for data exchange on the web. A client will make a HTTP request and the server will provide an HTTP response. There are several other protocols like SMTP, which is used for emails, and FTP, but you don't need to worry about those. Right now, we'll just be focusing on HTTP, and it's what's known as a client-server protocol. Again, just this whole client makes a request, server makes a response sort of deal. So HTTP requests, they consist of three parts: a request line, which consists of our HTTP method. So you see your post, a URI, also called an endpoint, can also be referred to as a route. So this /API/authors, it's kind of the end part of a URL. And then the HTTP protocol, which is really just the version of HTTP we're using. So there's HTTP 1.1, there's 2, there's some others. And then we have our header, which are this host, content type, cache control. At least for this workshop, you really don't need to worry about headers. They're just there in HTTP requests. They're used to, when we send our request, it'll give the server a little bit of information about our request so that it can sort of put it into context, and also an optional body. So here you see wrapped in curly brackets, we have a username and age, and that is just our optional body. There are several different HTTP methods. Right here is POST. POST is generally used for pinning something on a database or the server. There's GET, which gets something from the server. There's PUT, which is usually used for you editing something on the server. And also delete, self-explanatory, delete something off the server. So the reason it's an optional body is, say you're doing a GET request, you don't really need to send the server a body, because all you're doing is giving a GET request to the server and expecting the server to give you something back. You're not really wanting to give it a body to work with. However, in like a POST request, when you're trying to put something on the server, yes, you need a body because you need to tell it what to actually put on the server. And all a HTTP request does is prompt a response from the server. So what's an HTTP response? Well, it contains three parts: a status line, which includes, again, our HTTP protocol. Here's 1.1, and a status code. There are many status codes. It's like 100 through 500. More of the more common status codes are 200s, 400s, 500s, so it can be like 201, 202. One of the most common ones is 200, which basically is just a okay, it's good. Another common one is 404, which you'll see a lot, and the 400s, just as a note, are for client-side errors. 500s are for server-side errors. So a 404 error would be your client didn't render something properly. I don't have them memorized off the top of my head, but something along those lines. Anyways, the header, again, is just these little tags, so like date, server, accept ranges. Again, not that important, but it's just our server sending back some information about itself and the response. And again, an optional body, but generally when we're getting a response, we want some sort of body, whether that's an indication from the server, like what did it add, what did it post, or whatever we're getting, it'll send back. Maybe that'll be a web page, maybe that'll be some data. But other than that, an HTTP response is pretty similar to an HTTP request, but it's just sent from the server to the client. And just a short note, JSON, it's JavaScript object notation. Because we're setting up an Express server, I thought it'd be good to touch on this, because JSON is just basically how we format data, especially with JavaScript. It's sort of a standardized way to structure any sort of data on the web. It's useful for these HTTP requests and responses with sending bodies and getting bodies back. But this is pretty much what it looks like. It's not too important for this workshop. You can look it up. Also, I have some more information about it in the README. But other than that, I just wanted to touch on it and show you, hey, this is sort of the syntax for how we're, displaying our data, getting it from the server, putting it on the server. But yeah, there are other ways like YAML, but we're using JavaScript, so we're going with JSON. And I know this was sort of just a very high-level overview of what a server is, but again, I really want you to focus on your projects. I know you don't have that much time, so we just covered what is a server, hardware and software servers, server-side web frameworks, we touched on that. What is client and server communication, including HTTP requests and responses, and just a little bit about JSON. But now to get into the more technical side of things, and probably what you've been waiting for, here is the demo. We'll be setting up an Express server. Let me quickly switch screens to that. As Smallberg would say, maybe I'll spill some coffee on my shirt. Welcome back. Now we'll be doing the demo. I definitely spilled coffee on my shirt. It's not the same shirt at all. Just as a note, this is what the README and the GitHub repo looks like for the intro to servers. You can see here, there's the README, a write-up. If you click on demo, you can follow along. The first part of this is setting up your environment. You'll need a few things like a text editor. I'm using VS Code, Node.js. We're using the LTS version and Postman. So the links to download these things and get them set up right there. And some other information is here in the demo, as well as some of the code you can follow along. And there's explanations for everything. We go back up to the top. Here, server.js. This is the source code for our demo. We will basically be writing this, but in case you need to go back and look at it, it's here. It's all commented. So yeah, definitely check out this repo. But without further ado, let's get into the demo. So if we open up our terminal here, if you're on Windows, you can just use the File Explorer and basically make a new folder. But I'm just going to make a new folder called with dir called test server, and we're going to go into this directory. And if we ls, there's nothing in there. So what we will need to do to set up our project, we'll set this up with node. And again, feel free to follow along with the README. But basically, what we'll be doing is npm init. This basically just initializes a Node.js project. It'll prompt you with a bunch of stuff. Just enter to everything. Unless you want to fill in stuff like the author, feel free to. I'm not going to. And if we hit ls again, we can see a package.json. This indicates that our Node.js project was set up correctly. Then we can open it up in our text editor. You can either browse to that. If you do code dot, it'll open up your current directory in VS Code. So if we go into here, well, what we have here is our package.json. It's that stuff that we hit enter to. So you can see a lot of it's blank. It's just some information about our project. But if you open up the VS Code terminal, or you can do this in another terminal, it doesn't matter. View and terminal here. We need to install Express because we will be setting up an Express server in this demo. So if you do npm I, which is shorthand for install, you can also write it install and do Express. Boom. We installed Express. You can see it said added 57 packages, and we see this package log JSON pop up with a bunch of dependencies and these node modules. Don't worry about that. All we need to do now is create our actual software server. So all this is some code. Again, a software server is just some code. We'll name it server.js. And well, let's get into it. So first off, we installed Express, and now we need to actually use it. So we create this sort of Express variable, and we'll use require. This is just Node.js's version of like a C++ include statement. We're just including the Express module, and then we're going to make a new Express app with const app equals Express. So now our app is this Express app, and basically we have an Express server set up, except for the, again, requests and responses. So we need some way for our server to actually, listen for requests so that it can send back a response. And to do this, we will use something built into Express, app.listen. This will take a port and also an error function. Again, if you're not familiar with some of the syntax, please refer to the HTML, CSS, and JavaScript workshop where they cover JavaScript. And we'll also log it out just so we know that our server started correctly with just a short message saying server listening on port. Remember to use backticks and $sign and these brackets when you're trying to do like an F string. It'll just escape the string literal. Don't worry about that. It's just JavaScript. And because it's a variable, it's just nice to have our variable port be 3000. That's sort of like a test port for a lot of backends. You can use any free port, so 3001, 3002, doesn't matter. I'm using 3000. And now, if we do node, and we'll run this server.js with Node.js, you should get a message saying server listening on port 3000. And now, if we open up our browser and we go to localhost 3000, not 8000, you'll see this message, but this basically indicates that, hey, we have something up on localhost port 3000. So now let's try to display something on this endpoint slash. You can notice it'll say cannot get this endpoint, which is just a slash. It's also known as the root. This is saying, hey, our server is not being able to get anything. There's no request to get, and there's no response from the server. So let's add that app.get, because it will be a get HTTP method. And for Express, syntax is you'll send it first will be your endpoint or your route, and then the next will be an error function that takes two arguments, request and response. And then in our error function, we can basically do whatever we want with this. So we'll just send some basic HTML. We'll just do hello world. Cool. And just a note, whenever you are editing your server and you make a change and you save it, you have to restart your server. We don't have a build tool or anything like that to automatically refresh it for us, so we'll just do that. And then if you go back to this localhost 3000, and you can type a slash if you want to, it doesn't really matter, we see our hello world being served. I'll zoom in so you can read it. Hello world. Awesome. So now you have essentially set up what is basically an express server. Now, this sort of get HTTP request is part of what's called our API, Application Programming Interface. There is another workshop on APIs. Highly recommend to go check that out if you want more detail on APIs. I will be covering sort of a simulated users database and an API, manipulating users in that database. It's pretty much the basics. If you want more detail, again, go to that workshop. But anyways, let's get into actually making our database. So I'm not going to be using an actual database like MongoDB. All I will be using is just a simple JavaScript array. Now, this is very unrealistic for what an actual database would be, because it's just a local JavaScript array. Whenever you restart your server, whenever you make changes to your server, save and restart it, this JavaScript array will just be initialized again to basically these default users. I'm just going to use 3 users. That's fine. If you want to add more, you can just add, remember, commas. But this is just a JavaScript array with sort of a key value pair, an ID, and a name. It's not exactly a key value pair, but it is basically that. And then we will just, let's just do a request to get this database of ours, this JavaScript array of ours. I'm going to be using the endpoint user API/API/users. It really can be anything so long as it's valid. And again, another arrow function, and we'll send a response form of JSON with our users database. And now we made changes to our server. Remember to reset that. And if we go back to our localhost and we go to the endpoint/API/users, boom, we get our users. It'll most likely appear for you in this like singular line. We can just say users and each thing in our array, each user in our array. If you're wondering why we surround users with these brackets, these curly brackets, it's just something called destructuring. If you remove them, it doesn't really matter. Refresh this. Actually, we made a change, so let's restart our server. It just removes that users at the front of it. And it's nice to just know that this is our array of users. So I recommend doing this. You can look more into, it's called destructuring, but yeah, I won't be covering too much or be getting too much into the JavaScript syntax. But anyways, let's go on. Let's try to add a user to our database. So again, I'm going to be making a post request because we will be adding a user to our database, adding something on our server. We'll use the same endpoint because when we actually make a post, we're going to need a body which tells our server, hey, what user are we actually making? So it will know to do that. And also, whenever you're making a request, you have to specify the HTTP method. So in our case, we will be specifying as a post rather than a GET. Whenever you just put this into your browser, it's by default sort of doing a GET. Because for one, if we're doing a post, we can't really send a body just using our browser. I mean, there are ways to, and I'll be showing you a tool to do that more easily. But for our post request, we'll be just adding a user. So this will just be sort of JavaScript. We'll have a name variable that will be set to our request body, and there will be a name sort of parameter in that body, or name value. Because JSON, which is what we will be using to make our body, has key value pairs, and name will be sort of the key. We'll also need a new ID for the user, right? If we're adding a new ID, it'll just be incremented by 1, so that's what we'll do. Just to do this, we'll get the length of the array and plus 1. That'll be our new ID. Again, this is just more JavaScript. Really, this is not a great way to do a database, especially you probably won't be using a local JavaScript array, but I'm just using this to show you, hey, this is how we write a server. This is the API part of our server, and we can do things with our HTTP requests, get, post. But after this users.push just pushes this new user to the end of our array. That's what the push function does, and we'll just log this so we know that a user has been successfully created. Remember to use backticks because we're using these variables. And we'll also send a response from the server to the client with their status of 201. Remember, 200s are successful. 201 means successful creation, if I recall correctly. And we'll just send a response in the form of some JSON. Doesn't really matter, but this looks good for our post request. So now we made some changes to our server. Remember to save, and we'll restart our server. And now if we go back to our localhost 3000 in our browser, if we refresh, I just added back the destructuring, so we'll get users. But we get our database. We go back to the root endpoint. We get our hello world. But how do we actually send a post request? Right? We have no way to really send a body that contains our user. So for this, we'll be using a tool called Postman. In the README, there's some links. You'll need to set up a user account. And if you're using it in the browser like I am, you'll have to download something. It basically just lets you access sort of local URLs. But if we go to workspaces, new workspace, and if we go to new and do new HTTP request, which is what we're doing, it'll pull up this very nice clean menu. And for this, just to test it out, we'll be doing our get HTTP request right here, where we just want to get our user database. So we'll need to enter our URL, which is our endpoint. So it'll be the localhost 3000, and then our endpoint, which for us is API/users. And if we send this, we should get back this pretty version. It'll be JSON, right? Our users array. Looks good. If we do raw, you can see the thing that we originally get on the site. I'll zoom in a little bit more. But if we go back to this, right, it'll be that sort of ugly version. So Postman's pretty nice. It'll output this, sort of formatted well. But if we want to make our post request, we can go to post HTTP method, go to our endpoint, which is the same as our get request in this case. For headers, you can see a bunch of headers here. It'll be hidden. If you click hidden, you can see them. We don't need to mess with these, but just if you're curious. And then we need a body. So we'll be using raw, and we'll be using JSON, because this is what we'll be sending. And we'll just send it a name. This is how our request works. We go back here, right? We're just going to get the name value from our request body. And in this case, the name value, it'll be a key value pair. So key name, and our value will be some sort of user. Just do this user. If we make our post request, wow, we get this super long error. What could this possibly be? Now, whenever we're using JSON to send HTTP requests to our server, we need to have some sort of middleware in order to parse this JSON and let the server know it's JSON. And luckily, Express has this built in. So if we do .use express.json, this is just the middleware that parses our request JSON bodies. Just a little note, have to include that. And now if we save and we'll restart our server, we go back to Postman and we'll just get this again, just to show you our database is reset. We make a post to add this user, boom, we get back this request status 201 and the JSON with the new user, which we can see here, the new user, ID 4, name Hinata, and this 201 response here. This is where the responses are located in Postman. But yeah, if we go back to our GET request, we can see that our user has in fact been added back into the database. Same thing on this thing we're serving here. We can see that HOTH was added. So that is all good. So now you've made an Express server with a two GET requests actually, and a POST request. You've also used Postman to sort of test these requests, and you've done a little bit of JSON with sending that as a body. And now, just for fun and to demonstrate one last thing, let's do a delete request to delete a user from this database. So if we do app.delete and we go to an endpoint, we'll just use /API/users because we're manipulating users. We'll use something called a parameter. So anything with this colon, and then this is sort of serves as like a variable, is called a parameter. So ID is now a parameter, and this is what we'll be using to sort of select which user we're going to delete. Now, this isn't really a common way of handling deletion of users, but just for the sake of demonstrating parameters, this is what we'll be using. So first we'll just need to get the ID, which will be our request params. That's just short for parameters. So we're just selecting one of these, and we'll get the ID. And then we need to delete it from our array. So we'll just set an index, which is just -1. Again, this is just JavaScript. It's not that important for what you will be doing with your project. This is more just to demonstrate, HTTP request responses, writing your API, writing your server. But what I'm doing right now is just saying, hey, if our selection is out of bounds, we're going to send a status 404, which is a client-side error, if you recall, and just a little error message in the form of JSON, because why not? And remember backticks if you're using variables, and else, if it's actually inbounds, we will delete it from our array. So splice is what's used in JavaScript, and we will just log a successful deletion to our console. So deleted user with ID, remember backticks, and we will send a response. For this, we're just sending a response code, so you have to use send status right here instead of this status, and then returning some JSON with your response. Send status, if you don't use it, it will just like wait infinitely in Postman for like some sort of status or some sort of body in the response. We don't want that. So send status instead of just status. And this should be good for our deletion. So if we restart our server, go back to Postman, we'll do our GET request just to make sure our database is reset. You see it's a local array, so it'll just reset every time we restart our server. There's no more number 4 Hinata, but we can do this post request again and add Hinata back into our database. Boom. And if we want to test our delete request, it's delete, and our endpoint's the same, other than we need this parameter, which is the ID. Instead of typing :ID, we just type something. We can honestly type anything, but we want our endpoint to be correct, a correct ID. So in this case, let's delete which is ID number 3. So we'll add a 3 to the end of this, and we'll send it. And we're not going to get a body back in this response, but we will see our response code 204, which lets us know that this is successful. And if we do a GET request, can change the endpoint to see our database, we can see that ID number 3 was deleted. Now, in reality, you probably would want to shift all the IDs over or do something. Again, this is just to demonstrate server stuff, not really to demonstrate JavaScript and setting this up. But we can also see in our terminal, deleted user with ID 3 and create user with Hinata with ID 4. So that lets us know it's successful. And now you're pretty much done. You've set up an Express server. You've done 2 GET requests. You've done some JSON middleware, post request, a delete request. So if you're in an Express server with an API, you've got it to listen for requests, and you've also used Postman to test these requests. That is a very basic introduction to servers. Thank you all for sticking around, and happy hacking. I hope HOTH goes well and you're able to make a very cool project. So again, refer to the README if you're stuck. Detailed responses, you can go back in this video or the slides. But yeah, see ya.